Thermogravimetric analysis, TGA, is an analytical technique used to determine a material's thermal stability and its fraction of volatile components by monitoring the weight change that occurs as a sample is heated at a constant rate. TGA analysis is particularly useful for the following types of measurements: compositional analysis of multi-component materials or blends, thermal stabilities, oxidative stabilities, estimation of product lifetimes, decomposition kinetics. In this video, the application of TGA to determine the temperature to synthesize MOX material will be discussed. TGA can be used to identify the composition of nanoparticles, to determine the effect of additives and the assessment of oxidative and thermal stability. Nickel oxide is one of the most extensively used metal oxide. It has attracted increasing attention owing to potential use in a variety of applications such as catalysis, battery cathodes, gas sensors, electrochromic films and magnetic material. The calcination temperature is very important to prepare the metal oxide from metal hydroxide. On the other hand, calcinations is a commonly used treatment method to increase the crystallinity and activity of the prepared nanoparticles. To be able to precisely regulate the physical features of the product metal oxide, a complete understanding of the kinetic rates, processes, and pathways regulating the thermal decomposition of metal hydroxide is required. In a reaction mixture, dissolve 0.1 mol of NiSO47H2O using 100 ml of deionized water. Then, add 3 ml of ammonia. Throughout the procedure, remain the reaction mixture's pH at 9. Swirl the resulting mixture for 3.5 hours while maintain the temperature at 45 degrees Celsius. After that, eliminate the soluble contaminants through 3 washes with deionized water and ethanol. Heat the filtrates in a hot oven for 1 hour at 100 degrees Celsius. Finally, use a heating rate of 20 degrees Celsius per minute to obtain the thermogravimetric analysis on a Perkin-Elmer STA 6000. The primary weight changes that occurs in the temperature ranging from 30 to 110 degrees Celsius can be ascribed to the dehydration of lattice H2O from the synthesized nanoparticles. The second weight loss is observed at temperatures between 250 and 300 degrees Celsius. This is probably caused by the thermal degradation of nickel hydroxide to nickel oxide. There is a modest weight increase in the temperature range of 110 to 250 degrees Celsius, which may be caused by the endothermic reaction-assisted oxidation of the nanoparticle. The TGA curve shows that there is an almost 17% weight loss from nickel hydroxide to nickel oxide. As a result of TGA and DTG analysis, 300 degrees Celsius is considered to become the threshold suitable temperature for both methods in subsequent calcination procedures. TGA is useful in determining the temperature suitable for synthesizing a metal oxide as it involved a record of residual weight fraction against temperature for a sample heated at a steady rate. TGA portrays the thermal behavior of the oxide under diverse situations and only take a tiny amount of sample. Other characterization methods such as FTIR, spectrometry and XRD can be applied to further confirm the product formed. That's all from us. Thank you for your attention. You may scan this QR code that will direct you to the reference list.